Namaste, dear students. From ages, mankind has been looking for new and reliable sources of energy. The energy obtained from fossil fuels like coal and petrol is non-renewable, and the fact that it causes so much pollution encouraged us to look for renewable sources like wind energy and more alternative sources like solar energy, energy from the oceans, which causes no pollution, and we are trying to make it cost effective as well. By the end of our session today, you will be able to critically analyze the various sources of producing electricity or generating usable energy. You will be able to relate the process and phenomena of nuclear fusion and fission. And I am sure after understanding this, you will make sincere efforts to conserve energy and protect the environment. Have you ever wondered that so much energy is stored in the oceans? Let's talk about tidal energy. As the name suggests, this form of energy comes from the tides. But the question is, what are tides? Due to the gravitational pull of mainly the moon on the spinning earth, the level of water in the sea rises and falls. So if you live near the sea, or if you have ever travelled to some places near the sea, try and observe how the sea level changes during the day. This phenomena is called high and low tides, and the difference in sea levels gives us tidal energy. Tidal energy is harnessed by constructing a dam across a narrow opening to the sea. The turbine fixed at the opening of the dam converts tidal energy into electricity. The movement of the turbine is obtained from the high and low tides. As you can guess, the locations where such dams can be built are very limited. Let's talk about wave energy now. As we have talked about tides, similarly, the kinetic energy which is possessed by huge waves near the seashore can be trapped in a similar manner to generate electricity. The waves are generated by strong winds blowing across the sea. Wave energy should be used only where waves are very strong. A wide variety of devices have been developed to trap wave energy for rotation of turbine and production of electricity. Let us talk about ocean thermal energy now. As the name suggests, the heat energy stored in the ocean gives rise to ocean thermal energy. The water at the surface of the sea is heated by the sun, while the water in the deeper sections is relatively cold. The difference in temperature is used to obtain energy. Now, these plants can operate if the temperature difference between the water at the surface and water at depths are up to 2 kilometers is 20 Kelvin or more. The warm surface water is used to boil a volatile liquid like ammonia. The vapors of the liquid are then used to run the turbine of the generator. The cold water from the depth of the ocean is pumped up and condensed vapor again into liquid. This process is repeated and electricity is generated using the temperature difference between the depths of the ocean. Geothermal energy. Geo means earth, thermal means heat. Due to the geological changes, molten rocks formed in the deeper, hot regions of Earth's crust are pushed upwards and trapped in certain regions called hot spots. When underground water comes in contact with the hot spot, steam is generated. Sometimes hot water from the region finds outlets at the surface, and such outlets are called hot springs. By the way, coming back to the previous point, the steam which is trapped in rocks is routed through a pipe to a turbine and is used to generate electricity. The cost of production would not be much, but there are very few commercially viable sites where such energy can be exploited. There are a number of power plants based on geothermal energy operational in New Zealand and the United States of America. Nuclear energy. We are now shifting our focus to the basic unit of matter, which is the atom. Energy stored in the nucleus of the atom is called nuclear energy. How is the nuclear energy generated? In a process called nuclear fission, the nucleus of a heavy atom, such as uranium, is bombarded with a low energy neutron. And as a result of this reaction, the heavy nucleus split into lighter nuclei and 3 more neutrons. Remember, the mass of the original nucleus is just a little more than the sum of the masses of the individual products. Therefore, a tremendous amount of energy is released. The fission of an atom of uranium, for example, produces 10 million times the energy produced by the combustion of an atom of carbon from coal. So, in a nuclear reactor designed for electric power generation, such nuclear fuel undergoes a controlled fission reaction that releases energy also at a controlled rate. But the question is, how can we control the reaction? For example, after every reaction of one nucleus of uranium, 3 neutrons are produced. These 3 neutrons can cause fission of next 3 uranium atoms. Now, this process can continue, and this will be an uncontrolled chain reaction or a self-sustaining reaction in which the energy released can be devastating. If out of 3 somehow 2 neutrons are removed so that only 1 neutron is left to carry out the next reaction with 1 more uranium atom, then this reaction will be a controlled chain reaction. The heat energy released can be used to convert water into steam and further generate electricity. The major hazard of nuclear power generation is the storage and disposal of used fuel, because uranium is radioactive in nature, and after being used, it still decays into harmful subatomic particles. Improper nuclear waste storage and disposal results in environmental contamination. There is also a high risk of accidental leakage of nuclear radiation. The cost of installation of a nuclear power plant is quite high. The radiations can contaminate the environment and cause deadly diseases to living beings. There is a limited availability of uranium. So, all these factors make large-scale use of nuclear energy difficult. Nuclear energy was first used for destructive purposes. The fission chain reaction in a nuclear weapon like an atom bomb caused immense destruction and devastation in the past, which was just an uncontrolled nuclear fission reaction. In India, the nuclear power reactors are located at Tarapur in Maharashtra, Rana Pratap Sagar, Rajasthan, Kalpakkam, Tamil Nadu, Narora in UP, Kakrapar in Gujarat, and Kaiga in Karnataka. Currently, all commercial nuclear reactors are based on nuclear fission. But there is another possibility of nuclear energy generation by a much safer process called nuclear fusion. Fission means breaking or splitting, and fusion means joining lighter nuclei to make a heavier nucleus, most commonly hydrogen or hydrogen isotopes to create helium. It releases a tremendous amount of energy, and according to the Einstein equation, as the mass of the product is little less than the sum of the masses of the reactants, so the energy released is enormous. But the conditions needed for this process are extreme. Millions of degrees of temperature and millions of pascals of pressure. The hydrogen bomb is based on a thermonuclear fusion reaction. Children's sun, which is the ultimate source of energy, has nuclear fusion generating that enormous energy. We have studied various sources of energy in the previous sections. Please remember that exploiting any source of energy disturbs the environment in one or the other way. In any given situation, the source we would choose depends on factors such as the ease of extracting energy from that source, the economics or the money factor of extracting energy from the source, the efficiency of the technology available, and the environmental damage that can be caused by using that source. We have started using relatively clean fuels like CNG, that is compressed natural gas, but they have their set of disadvantages. We have already seen that burning fossil fuels causes air pollution. In some cases, a device like the solar cell may be pollution free, but the assembly of the device is expensive and would have caused some environmental damage. Children, the renewable energy which is available in our natural environment or is stored in such large underground reservoirs, the extraction of the usable energy from these renewable sources is practically negligible. Discuss among your friends why sun is the ultimate source of energy for sources like biomass, wind and ocean thermal energy. Is geothermal energy and nuclear energy different in this respect? If yes, can you find the reason why? And the most important question is, what steps would you take for energy conservation? So, till next time, keep practicing, keep questioning and conserve energy. Thank you and namaste.